Hello, everyone. This is Mark Herzog with BIC Magazine. Welcome to our webinar, Advanced Furnace Inspection Technology, Seeing Through the Flames. Anytime during the presentation, you can use the Q&A box to submit questions. The Q&A will occur at the end. There are widgets to access additional features such as the contact info for our presenters. There's a blue paperclip icon with, quote, related content. That includes a handout of the presentation. There's also a link to receive a certificate for attending the webinar today. Our webinar is sponsored by Teledyne FLIR Systems and Protect. Teledyne FLIR designs, manufactures, markets, and distributes thermal imaging solutions. FLIR optical gas imaging cameras help industry perform infrared gas detection, spotting methane, sulfur hexafluoride, hydrocarbons, and hundreds of other industrial gases quickly, accurately, and safely without shutting down systems. Excuse me. These cameras allow facilities to scan broad sections of equipment rapidly and survey areas that are hard to reach and can detect leaks from a safe distance in high resolution. Find out more at FLIR.com. That's FLIR.com. Protect is a leading national provider of safety, reliability, and compliance services, serving an array of industries, including refining, petrochemical, renewable fuels, fertilizer, and oil and gas. The foundation of Protect is built on decades of practical expertise. Protect specializes in protecting your company. Sorry, just lost my page here. There we go. Protect specializes in protecting your company from unnecessary risks related to employee injury, property damage, liability, unplanned downtime, and regulatory noncompliance. They are committed to providing best-in-class solutions so you can focus on what you do best, running your business. Visit them at protect.llc. Today's presenters are Craig O'Neill, Global Director of Business Development. Let me move ahead here. Okay, excuse me. Craig has been with Teledyne FLIR since 2002 and has played a key role in the optical gas imaging market since its commercial launch in 2005. He currently leads the global OGI business and strategy for Teledyne FLIR's oil and gas solutions. In his role, he connects customers, partners, and internal teams to ensure FLIR delivers effective sensing solutions across industries. Joining Craig is Jason Chakowski, IRT Thermography Manager, Level 3 CWI OSHA 30 at Protect LLC. Jason began his career as a high-pressure non-nuclear welder in the U.S. Navy and transitioned into non-destructive inspection, earning a CWI and certifications in multiple NDI methods. Over the past 15 years, he has specialized in infrared thermography, working across oil and gas, maritime, electrical, and aerospace industries, eventually becoming a master thermographer and subject matter expert at Protect LLC. He now serves as a Level 1 IR instructor for Infraspection Institute and partners with FLIR on advanced furnace inspection using the G609 mid-wave camera. I'd now like to hand the mic over to Craig.
Thanks, Mark. I appreciate it. And for those on the call, thank you very much for the time and to join us today. I'm excited to talk to you a little bit about one of our newest technologies with Jason here, who is just an amazing SME, subject matter expert on furnace inspections and really a great asset to FLIR as a customer and as a collaborator. Before we get into that, you may have heard some words like optical gas imaging. Why is that brought up? Generally speaking, our OGI cameras, or optical gas imaging cameras, and our furnace detection cameras are A, in the same market, but B, they utilize the same technology. So what we're mostly going to talk about today is kind of an overview of furnace inspections and how Jason can provide insight on how to make it a little easier. And also a little bit on the newest in technology that we have at FLIR. That luckily Jason was the earliest adopter of that, and can provide some really good field insights beyond that. Jason, I don't know if you had anything to add on the ProTech side, or to add a little bit for yourself there.
No, just it's excellent getting to use the newest and latest and greatest camera. We're happy to partner up with FLIR and do this joint adventure together.
Awesome, Jason. Thanks a lot. Before we get into the technology and the camera and some of the really great insights that Jason's going to hopefully be able to provide here today to those, I want to add that if you have some questions, drop the questions in, and we'll be able to hopefully get to as many of those as we can at the end of this. But before we get too deep, some people on the call may be very new to this entire application, and kind of go into what happens in an infrared furnace inspection. And reality is, what is a furnace? How does it work? And how do you do? Simply put, it's simply a fired heater, right? You're going to have, it's a part of the process within the petrochemical industry, in which you take a feedstock like crude oil, as an example. You take it and you run it through a bunch of tubes. You heat it up dramatically. And at different levels, you push it to the back end of a process where it cools down. And that's where you get the different types of product you would get out of a petrochemical industry, to be able, at different temperatures, as an example, as it's cooling down, to be able to get the product that goes to a consumer. And all we're doing in this thing is the very unique application of where we heat the feedstock to get it ready to go through the other types of a petrochemical facility, like a distillation column that you would see here. But what we're going to focus on today is only what's in the red rectangle there at the furnace side. If I were to push a little bit deeper into that and kind of how a furnace works, it's pretty simple in how it works, but the inspection process is quite challenging. Just, you can look behind me. I'm not sitting on a gas grill like most people feel. This is the actual tubes inside of a furnace. And what you can see is inside of a furnace is an extremely hot burner that pushes fuel, various types of fuel, maybe natural gas, that runs this and provides the heat inside there. But what is unique about it is all of that feedstock goes into these tubes, and it will pass throughout these tubes to heat it throughout the entire process. You can see the little drip here of oil. This is kind of what's happening inside of a furnace, right? We're going to have the actual feedstock running through the tubes as they're being heated by that burner. And at the end of the process, that just simply moves out of the heated feedstock area, out of the furnace, and into that next step that we talked about on the previous slide. So again, this is about as basic as I can make it. But as we get into actual applications, we can actually look at what happens inside the process, right? So Jason, if we're looking at the things that may happen inside this process, maybe walk me through a little bit of some of the things that cause issues inside of the furnace and that you might look for with an infrared camera.
Well, with these types of inspections, you get an internal fouling or coking. Burners are misaligned, so you get flame impingement. You could see refractory that's fallen or been dislodged. There's air gaps, which cause not effective heat. You could see items on the floor. I've seen thermal indicators, seen refractory. One of the biggest things, you can see tubes that are bowing or sagging, or they've been constricted, depending on the heater's orientation. Scale and oxidation, which are a big one, and that causes falsely elevated tube temperatures in most cases. And most of these other cameras cannot see this or have issues related to it.
Thanks, Jason. Yeah, and the great thing about these, most of the problems that you're seeing as you mentioned, a regular visual camera would just simply see the flames, right? And we won't get into the theory on this call, but When you point a regular camera, all you see is just this big flame. And if you point a infrared camera into a tube that doesn't have a unique filter in it, what happens in that regard?
So you're asking me, right, Craig?
Yeah. I mean, I'm just curious. Have you ever looked in it with a camera? Somebody said, "Hey, I've got a camera. Just look in here."
Well, there's a lot of people decide to put their iPhones up there and take images of it, and that doesn't their iPhone doesn't last very long. So you can see the flame pattern inside of a heater with a regular camera, but definitely with an infrared camera, if you were able to change palettes and you're able to basically move the thermal camera around, you can actually change when you see the color palettes change. They get that you can see the pattern and it hitting off the refractory, or when you get flame impingement.
Awesome. Thank you, Jason. So as we look at, kind of what does it, or how does an infrared camera help, maybe walk me through some of this stuff, and what are you doing with an infrared camera, specialized furnace inspection camera from FLIR? What are you doing when you're looking inside of a furnace as an expert?
You're looking for multiple things, not only the tube temperatures. You're looking for defects or scaling, like in this image right here. You're getting an actual tube temperature. Some of the other images you can get up in here with some ports you can't readily see, or sometimes the design of the port. I've opened port doors and there'll be a tube right there, or sometimes the port doors will be too narrow and you can't see it with other generations of cameras. So we're looking for broken tube supports. We'll show them in some different slides, refractory loss, and then overheating or coking up of internal fouling.
Thanks. Yeah, and if you look at some of the images here, the second image, it just shows the number of challenges, right? How hard it is to do an inspection. You may have to look through each one of these ports at a separate time, or you may have to go from one side of the furnace to the next, and being able to do that with the versatility of a handheld camera probably is pretty convenient, I'm guessing.
Oh yeah, definitely.
Yeah,
definitely.
And then you can see the image on the right. You've got a inside of a furnace with an infrared camera showing the difference in temperatures that a thermocouple may inspect. Where it kind of shows that if you have other technologies inside of a furnace, it could be a bit challenging to get in there and be able to kind of get a true visual experience of what's happening. But before we kind of get into that, maybe I'll go over the history of the cameras. Some of these I'm sure you're familiar with, whether they are, just a something that keeps you up at night as a nightmare that you had to use years ago. But just to kind of educate the market, right? We began doing this in the 80s, and it's hard to tell, but there's two cameras. One of them is a complete shoulder mount camera that had, yes, a 5 1/4 inch floppy disk in the back of it, right? So that was the beginning of furnace inspections. I believe you've used this camera, Jason. This is something that some people may still use today. It's 1990s technology. It's 1990s ergonomics and 1990s build. Have you used this camera? This is what we've seen. It's kind of one of the more popular versions. This is where we really got into making decent furnace cameras, but it's still 30 years old.
Yeah, definitely. I started with the PM390 camera, and one of the things that is definitely from the 1990s. And if you know anything about OSHA, there's no heat shield in front of that. And when the port doors seem to get larger, and it puts the operator at some disadvantage and actual safety concerns. So it was a rough camera. The battery packs were huge that you had to use with them, and it had a battery pack in the back of it. Was the lead cell batteries. Be able to get maybe 45 minutes out of them, maybe you get 10 minutes out of them now. So they've had battery changes. A lot of the cameras now from the PM390, you have to screw on a flame filter, so it doesn't take not in furnace issues take a digital camera, but it doesn't have a digital camera attached to it.
Yeah.
But for a safety concern, these are definitely outdated.
Yeah, you mentioned, the ability to actually protect both the camera and the user, and this is something that we came out with in the early 2000s with a camera that didn't work as well as we hoped it would. It was an uncooled technology. It also showed how uncooled cameras may have a bit more challenge in being able to provide the sensitivity and the image quality that you would need. But that was the first camera where we really put the design in front of the camera, right? What we mean by that is try to protect the camera as well as the user. And then I think the camera that's been the one that you've been using for many, many years is the 390. We did a couple of things. We reintegrated the protection, the shield, but we also added an extender lens to this to be able to make it easier. Did you have experience with that over the last 5 years plus?
Oh yeah, definitely. The 309 camera is a go-to camera in most cases. Having the lens extender was, being able to, I know you're not supposed to put the lens inside there, but you're able to articulate and see things you weren't able to see with the PM390 series cameras. It also gave the user a safety shield in front of it, and that was night and day difference. And then the image quality was much better. The absorption of the advanced filters. But the battery life was almost 4 hours on that thing, so that was definitely a plus.
Yeah, and what we look at that camera, and when we launched the new G series, we said, how can we make this? And yes, over the years from 2009 until last year with the GF309, we had a number of improvements. I won't go over all of those, changing the different ways the aperture works, the different filters that we put inside there, and then some of the hardware changes. And then now with the 609 camera, we'll talk about that, most of what we kind of visit on today. But we have with the 609 camera, you really kind of get all of that old school 309 type of features, but you get a lot more with 4 times resolution. With the 609 camera, when we get into this, reality is we visited a lot of users in the various markets that we use this, and a lot of them said, don't change the ergonomics, right? Don't change the hardware too much. We like the way this works. Make it better, make it easier. And we did a little bit of ergonomics with the way that the lens extender works, and we'll talk a little bit about that. But we provided better image accuracy, better details, more efficient workflow from both an LCD screen that's a touch screen all the way down to moving a workflow scenario, with the actual camera connecting with the software, connecting with cloud-based stuff, that's cloud-based storage that's built into the camera. So I think you've had some experience with this, Jason, right? I think you've used the GF309 with the lens extender and how that works. When you first got the 609 camera, what were your thoughts on the out-of-the-box experience, getting the camera ready to go into a furnace with the lens extender?
Well, the 309 had a major problem in having a collar put on the lens and having to put the lens extender on there. You would get what we call a halo effect. It would actually put a ring around it and try to get that symmetrical with getting it out of the field of view when you're looking inside of a furnace was very difficult. As soon as we pulled this out of the box, it was a wow factor that you guys incorporated the lens extender in with the lens. That, and you're able to move the heat shield forward or back, was definitely a plus, because in some applications you don't want to get the lens too close in there due to a negative draft, and you might suck the camera inside the heater, which nobody wants to do that. The definite plus is having to have the range button readily available on the side so you can touch it with your finger and actually move the range up and down. When you used to have to go in there and pull the camera back out, set the menu, and then adjust it there. Now you can do it just on the fly.
Awesome. Yeah, and if we look at some examples of what happens with this lens extender, right? You saw the previous one where you can actually more easily angle up, down, left, right. with a PM390, with any other infrared camera for this, a lot of them you would have issues with things like this, right? You get a lot of, you're looking into temperatures that you can see in here that are 1500 degrees, but the surface of the wall of the port that you'd look into is going to be much colder than that, just because it's not in the middle of the furnace. So you can see in the image on the top right where you may have 5 to 8 inches of a port wall to look through. Plug the camera right up with the heat shield, and again, as you said, you can slide that heat shield up and back. And I think that you maybe recognize this image, which is just a prime example of utilizing a lens extender. Maybe tell me a little bit about this.
So this is a bottom of a can heater. You can open a port with, and basically there's a sweet spot a couple of inches just below the port door on the bottom of the heater. And if you set the camera with the lens extender up just right, you can capture everything. It's the images on the left tube, we call that vignetting, which is you're getting an obstacle in between that's right in front of the camera, and the camera has a hard time, or the detector does, in my experience, has a hard time differentiating something that's 150 degrees, maybe refractory, and you're looking at something 1500 degrees, and the camera constantly wants to adjust itself. Using the lens extender on the bottom, and then having the heat shield there, you're able to capture this, and you're able to capture it safely.
Awesome. Thank you. And some of the other stuff that we did, a lot of these petrochemical, these places, they may have a handful of other cameras. They may have OGI cameras from FLIR. They may have temperature and measurement for electrical, mechanical. And what we've done is simply take the user experience. In the past, maybe a user of a GF series would be very different than one of a just temperature measurement camera. Now the touch screen, the way it operates, right, understanding what you're doing is a bit different. Having an expert is huge advantage, but as far as how the camera operates, you can streamline a little bit of that process. And in addition, we've added that touch screen into the camera, having the capability to inside either the heat shield or even what we would call the skirt that goes around this. Some people are using it, and some people may feel as though it's not, but either way, the heat shield is a huge advantage. But having the capabilities to do all that you need on the touch screen of the LCD, I'm assuming makes the inspection process a bit more efficient.
Yes, definitely. The easy use, and then actually showing the client who can go out there and they're safely able to see what's going on inside that furnace. I actually did that yesterday, and the client was just like, I cannot believe what I'm looking at, and they get the wow factor. Some people don't want to know, but other people want to see exactly what you're doing.
Yeah. One of the biggest advantages of this is with a furnace inspection camera, the capabilities or the ability to have more resolution simply means you get better measurement. You can get a better measurement over a greater distance. Not to get too technical, but generally speaking, most infrared cameras would average around 9 pixels to get a spot reading, right? If you look at that more in a true furnace inspection from an old camera, like a GF309 on the left, and a new camera, you can see getting 9 pixels, right, of an equivalent piece, you would get a lot of cold and you'd get a lot of hot inside there. Whereas on the right, you can really get 9 pixels that truly measures exactly what you're looking at. I know we talked a little bit about this, Jason. You sent me this image and said, hey, this is the ideal of what resolution gets you. Maybe talk to me a little bit about this picture.
So before like if you're looking through this heater right now, you can see the thermocouples on the right hand side, and you can see the tube hangers, and then on the very back end you can see the port door. You can actually see the port door in this. The refractory is kind of sideways a little bit. That I was never able to see this before. You're never able to get something that far away, and then as crisp and clear as this is, get accurate temperature measurements all the way back through the heater and up into the convection section.
Awesome, thanks. And then to kind of show technically how it's work, if you take some images, this is a 309 on the left and a 609 on the right. If you take some images and simply blow up the actual circle, you can see on the image on the left, you get a little bit of white inside the circle on the right half and on the left half. Whereas on the image that with higher resolution, the entire image is only the dark, right? That's only the actual tube itself. The image on the left is getting some of the hot wall inside there. What that does is when you're measuring with 309 or even like the old Informametrics PM 390s and 290s and a GEMA 550s for those that may still use those antiquated technologies, you're getting a much better temperature measurement because you have more pixels to measure on that. You're not only getting a better temperature measurement, you're also getting just an amazingly better image quality. You can see the actual definition on this. You can see the clarity of the image and just kind of, sometimes an image just tells the story. In this comparison, I don't know if you have anything to add on what's happening here other than just the kind of the detail clarity of that.
So on the bottom, on the left-hand image was the 309 camera. It got very grainy or pixelated in the back portion of it. On the right-hand image, it's crisp and clear, and you can see all the way back, and you can see the tubes in the convection, starting in the convection section. And if you notice, not supposed to see flames, but this might have been dirty gas or whatever we might like to call it. But you're able to see the gas at the bottom on the left-hand side, which was just phenomenal. Just the clarity it has.
Yeah. Thanks, Jason. Yeah, and the other thing that we've done to add some perfection, we've actually changed the way that we analyze the image inside the camera on the focus depth to make sure that we can get clean focus on things near ground and foreground, as well as things far distance in the background. And you can see the clarity of that in this image with just a both unique focus, but even the clarity to be able to see some of that flame impingement on the bottom left of the image. That's the 609. Some of the other stuff that we've done is to try to make the process more efficient. I know in the past, what you would do is you'd take just an SD card, take it out of the camera, you put it into a computer, you may run into some of that. But some of the huge advantages that we have now, that we've got Wi-Fi and Bluetooth built into the camera, but we also have actual cloud built into the camera, cloud storage, so that if the camera connects to Wi-Fi, it'll immediately upload any new images that are on the camera, and you can wirelessly transfer those down. I don't know if you have any input on that, just on how that might be. I don't know if you've used this yet, but how that might be really nice for the customer.
I haven't used it yet, just because the client doesn't have the software, but able to send the images right away to them is definitely a benefit. Not having to hand them the SD card and worry about it if you lost your shots and have to go redo them or anything, but having it Wi-Fi just as a game changer for plants that want to use that kind of technology.
Yeah, the great thing about it is if you create your own account, you can add guests, right? And so anything that you do, the images are in your folder, and you can also share that with external. The other great advantage of Wi-Fi you mentioned earlier, sometimes people want to see what you're doing. Looking over your shoulder can sometimes be a little challenge. Now you can actually Wi-Fi direct connect to an iPhone, or an iPad, and you can have a customer, as long as the iPad is safe to be used in that area, or the iPhone, you can actually have them looking at the live image of what you're looking at and be able to explain it without kind of the looking over the shoulder. So another huge advantage on the Wi-Fi. Another thing that is really nice and beyond that is because we now have the camera, we have built-in, it's called FLIR Ignite. Maybe FLIR Ignite's not the best petrochemical term for something, but we've got FLIR Ignite built into the camera, and that will allow you, because you can now process and communicate on cloud-based, you can build a pre-built route for your organization. So it could kind of help somebody like yourself have a trainer or help educate the customer on what they're doing or how to do it. For us as a customer, you can have a lead thermographer can build a route. And in that route, not only you can also go take images to show them, hey, this is what it's supposed to look like when you look at the top left, the bottom left, or anything like that. I don't know if you've had a chance to use this, but even if you haven't, would you see this as being really beneficial to an operator to have consistency in what they're doing?
Yeah, definitely. I don't personally use it because most of the plants that we go to, we shoot it in an exact same sequence, and we try to get repeatability. And a lot of customers want that repeatability. So I could see that'd be a benefit for somebody who was maybe a nested position, that they would shoot. They know they have 10 shots to shoot. They know exactly where to shoot it on the radiant section, the convection section, maybe shooting the burners, and that gives repeatability to that specific site. And they would get that kind of data each and every time they went out and did it.
Yeah, and just to show how challenging this is just an image I got offline online. Here it is. But each one of these areas, I've got 4 of the actual pieces built in there, right? And this is just 4 of a number that are within there, right? So if we were to highlight those 4 and then kind of point to where all you have to go inspect, right? This can be a bit challenging. An expert like yourself may have been to a single furnace every year, every quarter over many, many years, right? And so you may have your process, but when you may have a scenario where it's a bit newer, you have multiple people doing it that aren't as conveniently efficient, really adding this, and this is just an image I got offline as well, that was a really good stacked image, but shows the actual ports built into the furnace and where you might put a camera to look through there. So I know this is kind of hopefully makes the inspection process better, but whether you use the route creator or not, I believe you've used the software. I'm just curious, if you've seen the software a little easier. This is just an example, right? Just an inspector can go out, take a number of images. And now if you use the route creator, these can already be pre-built into a template. But even if you have your own methodology, I'm assuming, and maybe if you have any input on how the camera solution becomes more efficient, maybe saves time for you, maybe allows you to get home to your family an hour or 2 earlier than you may have in the past.
Yeah, first of all, wherever that plant is, I'd like to go shoot that anytime. That's a very, very nice facility. But having that, and then able to just knowing that you need 24 shots, knowing what sequence you get in, and not only makes the thermographer better when they go out there in the field, but they know they get repeatability and able to, you need 24 shots, you got 24 shots, go back to your vehicle or inside the control room, pull the pictures up on the camera, which is much easier now, and the software is much faster, and just check your images, double check your stuff, and you're out of there.
Yeah, that's great. Yeah, and then again, it's the one thing for the audience. The reporting is very simple. You simply can take, like you said, 20, 24, 50, 100 shots and just drag them into a predefined template that works for you. Now the report's made, and all you have to do is maybe go edit a couple of pictures that you knew about or that you see that may a different palette may show. I think you talked to me about how using a different palette may show some things. So you can make let's say a 20-page report and only maybe have to go edit 1 or 2 images. I think you mentioned something to me about that, right?
Yeah, definitely. You can, a lot of the times the customer wants to see what the burners are doing. And if by changing the color palettes in there and the amount of color palettes in there, and then able to scale it correctly, you can actually see where the burners are heating inside the furnace, whether the flames are going to the left or the right, or they're not burning enough, or you've lost a burner, or just the ability to see so much more with this camera. It's just changed the game for me.
Awesome, thanks. Well, I think this is where we kind of put you into your element now. And outside of mine as the technology guy, right, is maybe talk a little bit about the actual application examples that you've seen that we have seen throughout the time, and maybe you can help explain and use your expertise in the market. I'll roll through some slides here and maybe ask you to talk a little bit about maybe what you see happening in these images here. I think just before you start, the image on the left is just I believe it was something from us. We just took it to show, right? This thing is lit. You can't see the flame. You're close up. You can easily see that. That shows the flame filtering within the imagery of the camera, but maybe add any insights you have here.
Yeah, so it actually can see some of the gases, and being able to scale everything to on the software is just a game changer. On the right-hand image right there, one of my experiences that I had, so right here you can see 4 of these burners are out. 5 are running. Is this what they wanted? And then you're able to put that inside of a report. I've actually seen a gas line on the bottom of a reformer heater. I actually saw gas coming out, and a little bit shocking, not coming out of the burner, it was coming out of the floor. So this camera and the ability to get that crisp, clear image at, this is probably a 40-foot on 40-foot heater on the right-hand side, but you could see the air gaps in the back of the refractory being missing.
I'm guessing that a heater wouldn't work as good if it's running at 60% capacity.
No,
like
it wouldn't.
in this case. Yeah. I know that we talk a little bit about other technologies and other ways to look at this. On the left is really the challenges with thermocouples, right? They're more accurate because they can literally be touching something, but you never know exactly what they're touching. Are they disbonded? Is there some heat transfer within there? And on the image on the right, one you sent me on a pretty common thing that you may see that could cause some pretty big challenges with the tubes. Maybe explain some of these.
Yeah. So thermocouples, I've seen them all over the place. I've seen them laying on top of tubes. I've seen them sagging. I've seen them curling around them. To be honest, these things go off all the time, and they burn away. And I don't know, there's some good thermocouple company out there, but technology has changed, and I've seen ones that actually hug the tubes. They seem to get better readings. But on the right-hand side, once you lose a tube hanger, like the broken tube hanger right here, and you're able to articulate and move that camera lens in there a little bit better, customer never knew that they had broken tube hangers. So what happens then? Well, if that tube starts to overheat, obviously there's no fluid going through the tube hanger. The tube hanger broke off at one point, and then you'll get sagging tubes, and you can actually have a rupture from that.
Yeah, it doesn't sound like it would be a good day for them if something like that happens.
Correct.
I know when we hear about tubes and we hear about what to do, probably some of the 2 words we hear most common are scaling and coking, right? We hear about that. Sometimes it's challenging to tell the difference. And here's a couple of images that we've taken over the years with a scaling provided by a customer, probably pretty common to what you may see. And then some coking. Maybe explain those 2 phenomenons and how they're different, and how as a furnace camera expert, you can kind of utilize the better resolution of a 609 camera to be able to differentiate what you see there.
So in the scaling issue, scaling is actually when the tube actually starts to delaminate, and it actually will start losing some of the metal. And once you get an air interface in between the tube and the actual scale, the scale is actually going to heat up, give you a falsely elevated, we'll call it a tube temperature for most cases. But it's hard to put the spot meters or box or line meters on there because how much scale is actually on the tubes themselves. I don't know how the reliability engineers determine how much scale they can lose or whatever the case may be. But a lot of the times when they go in there and guys go do UT readings, they'll buff a little spot off in there, and that'll be the cleanest spot so that we get accurate readings. On the right side, you have internal fouling or coking. And if you see there, the 1, 2, 3, 4, the 5th tube up, kind of like dead center right there, that's off the tube support for some reason. It's not laying in there nicely, or it's bowing, or maybe it's supposed to be there. I don't know. But that leopard print, that patching, that's all internal fouling. Mm-hmm. And being able to tell, at ProTech, we teach our guys exactly how to differentiate between scaling, coking, internal fouling, flame impingement, and refractory loss and air gaps.
Yeah, I think the most simple term I've ever heard is the scaling's on the outside, coking's on the inside, and scaling's kind of like, again, when you get some skin issues and you get a sunburn, some of your skin comes off because your body's trying to fix it, right? And the same thing there. And that would be kind of the external temperature issue. The inside is going to be because of buildup, right? I believe on a simplistic point, the coking is just build up. At least I think that's kind of what I've seen.
Correct.
The other thing you just mentioned on the image on the coking, but you sent me a couple of pictures, right? And we talked a little bit about the challenges with bowed or bent tubing. Maybe, and I think we talked a little bit about these images, and I'm curious, if you have any insight, or what kind of problems can this cause a petrochemical facility? Like, what's the worst thing that can happen if one of these, whether it's the coking issue, the scaling issue, the bowing, what's the worst thing that can happen in these cases?
Obviously, they rupture a tube. That'd be the worst case scenario. But tubes, I've often seen tubes bent or bowed. Sagging tubes is a real problem. So that's a big issue. I believe the image on the left-hand side was a 309 camera. I'd be curious to shoot this again. I will at some point here get to use the 609. The right image is a 609. The customer had no idea that the tubes actually they touched, and that can create different issues. Obviously, you see the on the right hand image, and sometimes at ProTech we give the customer. I sit down with the customer for like 15 minutes and say, what color palette do you want this in? Because some people are colorblind and they want it in black and white. Some people can see different things. Some people want it in the iron. Some people, I don't shoot things in rainbow high contrast, but this image on the right with the rainbow high contrast actually shows you that in the center of that image, that's where the hottest point is. Did that cause that tube to move over or not? I don't know, but that's something that when I handed that that report to the inspectors, they said, we want to monitor this more often. And we weren't able to catch that image before.
Yeah, I think that also kind of shows the ability of the software with the camera combined, being able to do that, have all the images in the cloud and shared with them immediately, may be able to help that. I think that we talked a little bit about it in some research you did, is that, loosely said, an increase in temperature of around, I think it was 10 degrees Celsius, I believe you mentioned, that could potentially take 10,000 hours off the life of a tube, right? It seems to be that seems like it could be pretty disastrous for the lifespan and the longevity and realistically the efficiency of inside the actual furnace itself.
I agree.
Now, another thing, outside of the common coking and scaling and broken hangers and tube, these are some unique pictures that you shared with me that you've kind of seen in your experience. Maybe talk a little bit about what you see in these couple of images.
So on the left-hand image, it was evident even by eyesight. Not that we want to put our head next to that. Is a reformer heater on the left-hand side, and you don't see much of the refractory on the top left. But this image right here, the flames were just like a blowtorch to this furnace, and it was just not known that they were getting that much flame impingement. And being able to show the customer, hey, this is what you've got going on in here, and what are the true temperatures? And here, it's difficult to do reformer heaters. I don't want to get into the entire portion of the reformer heater, but on the right hand image, being able to articulate the image down and actually get the bottom where the tubes are coming out of the floor, they didn't know that they lost a big chunk of refractory. And so now that they know that, hey, there's something going on here, just like I said, because we couldn't shoot this one up, we didn't know where it came from, but you can monitor that, and then, the next time you go out on a quarterly, you can match up these images, and the camera's just awesome for it.
Great. One of the images that I like showing is a customer of ours years ago, and I think this is a pretty common process. What you see sent us what happens before and after you do a steam air decoking, right? So here's some images, and you can see the coking, you can see the buildup. I think you called it the leopard print, the smooth transitions of colors where it would be coking, and you can see the actual temperatures themselves from 475 up to 500 and 37. What they did is they did a steam air decoking process and went back out with the camera and took exact same imagery, right? Now the numbers 389, 387 to 390, and you can see the clean imagery. All of these images have the exact same level and span, right? The minimum temperature and the maximum temperature exactly the same, and tried to put the temperature spots as close as I could on each different image. I think that this kind of shows the before and after in this case kind of shows the effectiveness of being able to know where to go clean, when to go clean, and how to use the furnace camera, right?
Excellent. Yeah, definitely. We talked about this. That's an excellent representation of a good steam air decoking. And now you notice that the temperatures aren't all over the map like they were before. And when you get something within 10, 15 degrees, you're on the money and you did it right.
Yeah, and again, not just for preventative maintenance or for inspection, also for Q&A, right? To make sure the process works good, cameras can be really good. I know you are a level 3 thermographer, and you've got a lot of experience even outside the world of furnaces. Maybe talk to me about what you may do with one of these cameras that doesn't only work in furnaces, right? A huge advantage. It doesn't only work in this 1,000 degree and up. Maybe tell me a little bit about what you might do for a customer outside of true furnace inspections.
So at ProTech, we do about everything. So we do electrical inspections, piping inspections, tank level indicators. And like I said, we give the customer the opportunity, hey, which color palette would you like? How would you like this in? Externally, shell inspections were refractory lined, high temperature equipment. The cameras now that we're using 640 by 320, and the resolution is just absolutely incredible. Even the tank level indicators, you could see sludge, vapor, some sand accumulators. We've actually seen some of that. Heat exchangers, you can actually see if heat exchangers are working. We do photovoltaic systems. We're getting at ProTech, we're getting someone on board right now he's a drone pilot. He wants to we're going to put an IR camera on the drone, and that'll bring us into the roof inspections and FLIR inspections and other stuff like that.
Awesome. Yeah, I mean, like I said, it's a wider range. In essence, anything that can cause temperature change, anything that can change the surface temperature of something, whether again it's a roof with moisture issues or a tank or electrical failure. So yeah, it's a huge wide variety of what we're able to do with the technology. Jason, I want to thank you, right? I want to thank you for coming on the webinar with me, talk a little bit about the furnace inspection technology. It means a lot to myself, it means a lot to you. I know, we both built some careers around this. I wanted to also see maybe if there's any questions from the gallery that we may want to talk about, or Mark, if there's any questions that you want to throw at myself or at Jason that we can maybe help out with.
Yeah, actually, we got quite a few questions come in. Two of them I'm marking as already answered, because on your last, you covered all the applications or some of the additional applications for the cameras, and that was one of the questions. Let me jump into one of these technical questions here from a refinery. For target temperature estimation, how is the emissivity and the reflected temperature estimation done? Is that something you'd like to drill down to?
Jason, you want to take that, or you want me to kind of take a stab at it?
Well, no, it's the emissivity. Each furnace is unique in what they have. There's emissivity settings that we have. There's I give my clients an emissivity table. You can do it by targeting. Stainless steel actually has more reflectivity, so it would be a lower emissivity. You kind of want to target that in between the reflected temp, emissivity, the target you're looking at, and kind of put that all in one.
Yeah, I believe a lot of the material, right, the tube manufacturers may even present an emissivity that they would have, right, for their exact thing.
Correct.
And being an educated and an expertness and trying to understand, just for those that may be on the call that don't understand, to get an accurate temperature measurement, right, you would need to put in a relative emissivity of what you're looking at, but also understand, because part of the values or the calculations for the temperature measurement include emissivity as well as background or reflected temperature. If you're looking something at an angle, it could be the background. It could also be that reflected specific temperature. So we do give you the options in the camera of putting that for the holistic image, right? Which there's some companies that say, you know what, we're just going to put a special number, right? It's going to make it perfect for the whole image. But the reality is each individual spot within our software can be changed individually, because there may be some differences depending upon a near angle and a far angle of what you might be looking at there. And so we have the capability on our technology at an individual analysis tool as well as the scene image. But a lot of the times, in something like this, it seems like just saying we have a magic number that's going to make it work for the whole image may not be accurate in what you're able to do. If you look at some of the images, right, the emissivity of a hanger may be different than the emissivity of a tube itself. And so if you have two spots and you want to try to get as accurate as you can, you may want to be able to look at those a little bit differently. Do you have anything, another one, Mark? I think I've seen some popping up.
In relationship to heater tubes, does the camera have the capability to detect elements related to poor desalter operation in a crude unit, such as calcium and magnesium? We have learned that poor desalter operation can increase fouling in heater tubes. Comments?
I'm going to have to leave this one to Jason. I'm not as experienced, and if we need to maybe do a little research and get back to somebody, Jason, I don't know off the top of your head.
No.
Do you have any thoughts on desalter operation in a crude unit and what happens there?
No, but if I can get a better outline or maybe a phone call or something like that, I'm sure I can handle whatever the question may be. But one of the questions I just saw pop by, emissivity does change with the temperature of the tubes. Just to let everybody know that. Not to give away the trade secrets on how we're getting all our images and everything correct, and our temperatures for the clients. Repeatability is the big thing. That's what I want to kind of get at with this. If the emissivity is off here, can we repeat that same thing every single time we go out there and shoot it?
Yeah, Mark, I see one of these. It just says calibration. Maybe I'll take that one, right?
Mm-hmm.
That we do at FLIR, we do calibrate our cameras directly. Each camera is calibrated with each individual lens at the factory. That calibration is made to hold for realistically, we would like to say the lifespan of the camera, but the reality is maybe it's not. We have customers that have used the same camera, sent it in 10 years later, and the camera was spot on calibration. Sometimes that calibration may drift. So we do offer calibration services. There are customers that want to be NIST compliant, and for that, they may need annual calibrations. We can do that. I look at it more like your car, right? You may need to service change the oil and fill it up with gas, clean it, all of this on a consistent basis. But every couple of years, you may need to go do a transmission check or some of the brake fluid or some of the issues. So I'd recommend, a camera coming in, depending upon if you use it 40 hours a week or whether you use it 40 hours a month, may change the timeline. But at least sending it in every, 2 to 3 years let us just check it out, clean it up, we'll calibrate it and do that. We are the only ones that can calibrate our cameras. There are files built into the cameras that allow that are only accessible by an authorized FLIR calibration and service facility. So those that are telling you, we can just take the FLIR camera and we can calibrate it for you, they don't have access to open those files, and they don't have access to our calibration curves to change those unless that is calibrated at an authorized FLIR service center.
Very good. Do you want to scan some of these remaining
Yeah, I'll scan a
questions?
couple and maybe run through these. One is does one SD card work to build a route for multiple equipment, or do we need an SD cards for each equipment? No, this is built. You build an actual program, and it can go on one. You can call route one being a certain part of the business, right? So maybe you have a furnace inspection route, and then you also have an electrical inspection route. And those can be on the same card, and that's built in the software, and it has its own name to be able to do that, right? The price on the new imager, I can give you US dollars. There's a lot of variabilities in the US dollar and how much things are going, right? But these are over $100,000. They're an expensive piece of technology related to that, but I think Jason could probably provide a number of examples if we had time to just explain how you can get that value back by saving pipes, by saving a facility from going up. I don't know, Jason, has there ever been a time where you did an inspection, maybe they didn't get to it fast enough and something bad happened?
Yeah, I've had a facility I was shooting repeatedly. It was on a weekly basis, and it would happen to be that on a Friday. I actually called one of the chief inspectors and said, "Hey, you have 135 degrees above critical temperature." And he said, "Are you sure?" And I got that question asked, "Are you sure? Are you sure? Are you sure?" And I said, "Yes, I'm positive. I've checked it. I've done the math 3 different times. You're over." They didn't get to it fast enough. 2 days later, it happened to be at 3 o'clock in the morning. They ended up rupturing 3 of those tubes that they had pinpointed. So,
oh wow.
Some of these other cameras that are out there takes two to 3 people to operate. They have to stick it through viewports or actually enter it inside the heater, which I don't know how you get a permit for that because some of them run on compressed plant air.
Oh wow! You have to bring a hose up there, right?
Not only that, you're not doing one person. You're not. You've got multiple people up there, and you've got multiple ports you're putting it in, and the reporting time. I mean, ProTech prides ourselves on our reporting time. We normally have a 72-hour turnaround, and if it's beyond that, it's because I'm gone in 50 different states at one time. But just the speed and the accuracy that we're able to get this back to our customers sets us apart.
Awesome. There's a question. I think these cameras are just used for the purpose of when the process is shut down. The answer to that is no. You are doing all of these inspections when the furnace is in full operation. You do not need to shut it down to do any of these inspections with our furnace inspection technology. Is that correct?
That's correct, as long as you have a negative draft.
Yeah. Okay. Maybe a couple more. Can you view through viewport glass? The answer is kind of, but the reality is you're not going to get accurate temperature measurements if you're viewing through a viewport glass. The midwave technology does see through most forms of glass, but the thickness would change and all of that. It'd be very challenging to get accurate temperature measurement. Jason, maybe this is more for you. How effective is the camera at detecting a flame boundary apart from the various surfaces? Does that, do you understand that question? I think I might, but
I'm not sure about the flame boundary. Is it referring to?
So I think what they're asking is, can you see like where the flame is going? The answer to that is no, right? This is what's unique about the camera is that we see through the flame, right? So when we see things happening, it's because the flame is changing the surface temperature of something else, right? So if I go back to the first image that we showed related to the furnaces, there is no flame boundary on these 6 active burners. We're seeing through that flame 99-ish%, 99+%. So we do not see any flame boundary unless that flame touches, and that's where you would define it as flame impingement. Software licensing costs, we do have a free version of the software. So if you're an operator that would want to use the camera, or if you're an operator that may have a service company and needs an expert like Jason, but also wants access to some of those images, there you go. We have a free version of the software. We have various levels from a professional version that allows you to create all the reports and do everything that you would want, like Jason may use, all the way down, and the cost varies depending upon the version, and we have all of that online, and we can provide a post of that or get back to you. I think it goes up. It's usually just a yearly service. I think it's $200 or $300 a year for the top end software that we have related to Thermal Studio or inspection software.
Okay.
I think
one more.
We're running, I think, on the back end of time here, Mark, and I see some other ones come in, but I think that we may need to reach out to some people independently and specifically, and we'll have everybody's questions and be able to answer those offline after this. But I know we're right at the 1 hour mark.
Very good. Yes. So thanks everyone for being here. We will get to additional questions by responding via email. If you have a question you haven't asked or you want to follow up on anything, you can email Craig or Jason. You can see their email addresses on the screen there. So I want to thank you both, Craig and Jason, for the presentation, and thanks to our sponsors, Teledyne FLIR Systems and Protect. A couple people did ask, can we watch a recorded version of this? Yes, it will be posted on our website in about 2 hours. Use the same link you used today or visit bicwebinars.com. In addition to that, please do bookmark bicmagazine.com for access to articles, podcasts, and videos on the news and knowledge you need to navigate your business and nurture your career. Please visit our sponsors at their respective websites and have a safe day.
Thank you, Mark.
Thank you.